Welcome to our study on quadratic functions. Today we look at finding the coordinates of a turning point of a quadratic curve or a curve. So the function of the form y is equal to ax squared plus bx plus c is a quadratic equation where a and b and c are integers. So our turning point of a quadratic equation or a quadratic function is given by negative p comma q. From our expression here, there is no p, hence there's need for us to express this equation in terms of p as well as in terms of q. So how we do it is, in the quadratic function, if your a is different from 1, then you have to factor out the a so that you can have your x squared have a coefficient of 1. If your x squared from the beginning already has a coefficient of 1, then all you do is get half of the b. So number 2, you introduce a special 0. What that means is what you have is ax squared plus bx plus c. So we introduce a special 0 by adding and subtracting half of b over a squared and subtracting the same thing. So what we have is ax squared plus bx. If I add this, I'm going to have 1 plus b squared over 4a squared plus c minus b squared over 4a squared. Now this and this, when I put them together, they'll just give me a 0. So I'll end up with the same variables that I had in the beginning, which is why we're calling it introducing a special 0. Then 3, you express the quadratic function in the form y is equal to x plus p squared plus q. So let's have an example so that we can have a look at how the final stage is done. So express y is equal to x squared plus 6x plus 4. Our coefficient of x squared is already 1, so there's no need for us to factor out anything. So we have y is equal to x squared plus 6x plus 4. Our second stage, we get half of b, we add, as well as the same half of b, we subtract. So we're going to have x squared plus 6x plus half of 6, because our b is 6, plus 4, the same value we've added here, we subtract it here, half of 6. This and this will give us a 0. So that we can simplify this to x squared plus 6x plus 2 in there, it's 1. So the half of 6 is 3 plus, this should be squared, 3 squared plus 4 minus 3 squared. Having done that, that will simplify to x squared plus 6x plus 3 squared plus 4 minus 9. Now, these first 3 terms that you have there simplify to x plus 3 squared. How? If you use your product and sum, you to be factorized to this, or much simply, whenever you have this expressed like this, just get the x without the square plus the value that you have here. So what you have is plus 3 without the square as well, then you square everything all the time. So 4 minus 5 will give us minus 4 minus 9 will give us minus 5. So now we have our quadratic equation looking like this. We've expressed our quadratic function in terms of p and in terms of q, meaning that our p is 3 and our q, which is in this place, is negative 5. Therefore, our turning point is, remember your turning point is negative p comma q, so that will just be negative 3 comma negative 5. So this curve, or this quadratic function, if plotted, the turning point will be at this point, negative 3 comma negative 5. For our second example, express y is equal to 3x squared plus 4x minus 6 in the form this, and then state the turning point. So notice that the coefficient of x squared is 3. Remember that our task is all the time to work with this function with the coefficient of x squared being 1. So let's factor out the 3. So we have y is equal to 3x squared plus 4x minus 6. So y is equal to, I factor out the 3. So 3, I have 3 into x squared will just be x squared plus 3 into 4x will give me 4 over 3x minus 6 over 3. I've factored out my 3. Now I have my x squared with a coefficient of 2. The next stage, I introduce my special 0. So we're going to have, let me write it here, we're going to have y is equal to 3x squared minus 4 over 3x plus my special 0, half of b. Our b position now has 4 over 3, so half of 4 over 3 squared minus 6 over 3 is just 3, so we'll simplify it later, minus, subtract the same number we've introduced here, so we're going to have half times 4 over 3 squared. So 2 in there it's 1, 2 in there it's 2. So this will simplify to 3x squared minus 4 over 3x plus 2 over 3 squared minus 3 into 6 is 2, then minus 2 over 3 squared, equally these will reduce. Then we're going to have 3x squared minus 4 over 3x plus 2 over 3 squared minus 2 minus 4 over 9 if I expand that one. Notice we always just expand our last term. This one here we leave it to the square because we need it as we change our quadratic function. So we have 3, we have brackets at the end, we have 3, this we get our x without the square, and we get the last term of the 3 terms we have here. So we have 2 over 3 squared minus, then if you simplify this one here, you're going to end up with minus 22 over 9. We have brackets. So before we get our p, remember that we factored out this for everything here. Let's redistribute it again. Let's expand or break this bigger bracket. So we're going to have 3 times x plus 2 over 3 squared. Negative times positive, it will still be negative, and 3 times the last term here, 3 in there is 1, 3 in there is 3. This will give us 22 over 3. So our turning point will be negative, what we have in place of p is 2 over 3, so negative 2 over 3 comma negative 22 over 3. So our graph would turn at that point. Then I have a task for you. You try finding the turning point for this quadratic function and show that your answer will give us our turning point of 5 over 2 comma 41 over 4. Thank you.